Hello and welcome to the InfoQ podcast. I'm Daniel Bryant, News Manager at InfoQ and Product Architect at DataWire. And I recently had the pleasure of sitting down with Lin Sun, Senior Technical Staff Member and Master Inventor at IBM, and Neeraj Poddar, Engineering Lead and Architect at Aspen Mesh. Recently, the InfoQ team and I published an ultimate guide on the topic of service meshes, which you can find at infoq.com. As a result of this, Neeraj and I had exchanged a few emails discussing the use cases for service mesh and also exploring what the future holds in this space. When he referenced some of the things that he'd learned from Lin and her very interesting work around Istio, the idea was born for us all to get together and discuss this topic in more depth. Istio is a service mesh that was originally created by Google, IBM and Lyft, but now has a very large community of people and organizations contributing to it. Both Lin and Neeraj are very active within this space. Although other service meshes do of course exist, I was keen to dive into the recent developments within Istio, particularly the 1.5 release, which included several architectural changes, for example moving to a monolithic control plane, and also the addition of WebAssembly or Wasm support for creating plugins at the data plane. Hello Lin, hello Neeraj, welcome to the InfoQ podcast.
Yeah, hi guys, super excited to be here.
Hi Daniel, it's nice to be here.
Could you briefly introduce yourself please and share a recent career highlight or background?
I'm the co-founder and chief architect at Aspen Mesh. I've been working in the service mesh and Istio space for the past 2.5, 3 years with Lin and a bunch of other good community folks. As for the highlights go, I think one of the best parts of co-founding a company is seeing the company grow. So I've seen it grow from 3 people to now 25 plus. And it's amazing to see how much people can take on hard challenges and come out of the end of it with bright colors. So I really enjoy that part. I'm still enjoying it as our team is growing. And working with the Istio community and making folks from our company integrate with that has been really satisfying. So that has been a really good highlight for me.
That's awesome. Hi, my name is Lin Sun. I'm a senior technical staff member and master inventor at IBM. I've been on the Istio project for a long time now, almost 3 years now. Looking back at the highlight, I guess last year, me and my co-author Dan Book actually produced a book about Istio. Istio Explained. It took a lot of nights and weekends effort, but it's interesting to be able to put some documents together for a user from different type of scenarios, how user can adapt Istio, how user can look at the landscape of service mesh. So that's kind of a small highlight, but we're really committed to this project.
Awesome stuff. I know starting a company and writing a book are both amazing achievements, so kudos to you both there. Now, obviously, company here, we've been talking about service mesh on and off for many years now, but I still bump into many folks there. This is new for them. So I wouldn't mind to get your kind of take on what the problem space is or the motivations for service mesh.
I guess we've seen a trend of people moving from monolithic to microservices. As part of that trend, as people go into microservices and cloud native, we've observed that there's a common set of problems among these microservices that many people start trying to solve. For example, how am I going to connect to my microservices? How am I going to do retries? How am I going to observe my microservices? How am I going to secure the communication of my microservices? How am I going to enforce policies on my microservices? So we've seen a set of problems and people start to solve them for each individual language, like Netflix OSS. So I would call it like first generation of service mesh, specifically for a particular programming language. And then we've noticed the trend. People are not going to always write in one language. They're going to start with multiple different languages. I think that's when the service mesh notion was more formally born, around using a sidecar proxy to be able to take care of all that for microservices and then have a control plane to allow user to intelligent program their sidecar proxies.
What Lin said makes a lot of sense. I think for me, another thing to add on that will be, as companies have been moving, or traditional enterprises are trying to compete with innovators in this space, they're realizing that the real competitive advantage is their developers and the ability to add applications at a far greater pace than their competitors who are trying to disrupt this space. So in that sense, as people are moving towards microservices, they realize that a lot of the work in microservices from developers gets tangled with the work with operators. And that's what a service mesh gives you, in addition to what Lin said. It gives you a way of basically separating those layers where each of those personas can do their own work and still be successful and give the best outcome for the company. Operators try to enforce organizational policies, and they were able to do that in monoliths through creating load balancers and network devices like big IPs and whatnot. You want the same policies, but you don't want to push that burden on developers. So that's what Service Mesh gives you, that decoupling between the operators and the developers, in my mind.
Another problem that I see folks sort of getting their head around is this notion between a control plane and a data plane. Now, Lin, you already mentioned about the sidecar proxies there. Neeraj, you sort of mentioned on some of these topics as well. Would one of you mind break down how you see the control plane and the data plane, please?
Whenever you have application data flowing through in your system, you want that application data to actually flow through the minimum thing so that it's performant, but you still want to apply those policies. So in the Istio land, wherever your application data is flowing through is what constitutes data plane. And this is mostly the gateways and the sidecar proxies, which are collectively making up the mesh. But now, as an operator and a user of the mesh, you have to configure things. You have to configure things in the language of the platform that you're comfortable with. So that's where the control plane comes in. Control plane takes in the user provided configuration, whether it's a platform configuration of Kubernetes or Istio specific configuration, and provides an abstraction layer and converts it to a data plane specific configuration. So it gives you the right separation. At the same point, it makes the data plane more pluggable. So in future, we have the flexibility of switching out the proxy if we want. So I really like the way Istio was started with this flexibility in mind, and this nice separation fits very well for people who are used to this paradigm in traditional networking.
Yeah, I totally agree with that, Neeraj. One addition I would add is from a user perspective, it has been providing tremendous value to our user to have that abstraction layer provided by the control plane. Because one time I actually did an exercise myself. So I deploy like simple book info, sample of Istio, and I took a peek of that proxy configuration of one of the microservices. There's like thousands of lines of the Envoy configuration, and I'm not even doing any fancy. It's basic round robin routing and maybe a header-based routing. That's it. So what Istio really provides is through Istio resources to kind of having user to programming with the abstraction layer for virtual services and destination rule and be able to interact with control plane and then have that configuration translated to a much more complicated Envoy or whatever proxy configuration it is. So that's real value to our user without needing to understanding all the detail of the proxy configuration.
Perfect. Yeah, I love Envoy. I obviously work with Envoy a lot, but I don't think anyone would deny the configuration language, the YAML, the JSON. It's designed to be machine written. It's very verbose. Yeah, so I totally get your pitch around the control planes. You've already mentioned it. Both of you are big Istio advocates. I would say other service meshes do exist just for neutrality purposes, but Istio has been coming along in leaps and bounds. I sort of keep an eye on the project, and I noticed over the last year in particular, it looked really nice. 1.5, the release, really, really good stuff. So say for folks that have heard of Istio, maybe not paying too much attention over the last 6 months, could you share some of the highlights in the project, please?
So for Istio 1.5 particularly, I think one of the major highlights is really make sure user can easily deploy and operate Istio a lot easily. Because prior to 1.5, user would have to worry about multiple components of control plane. That means they would have to worry about checking out the logs for multiple control plane components, make sure each of them are upgraded correctly, make sure each of them have the right scaling policy, make sure they are healthy and up running. But with 1.5, there's a big change in our control plane components that we are actually merging all these control plane components back into one single control plane components called Istio Daemon. that really simplify operators and administrators to be able to kind of install and deploy and upgrade to be able to manage that one single thing. We're also seeing on the multi-cluster land, which is where I spend primarily my time in the project now, that the remote cluster, it's actually much easier to config to talk to the primary cluster per se, the other cluster when you have multiple cluster of Istio, because of that one single Istio daemon. So it's tremendously simplify the configuration for that.
Yeah, and an interesting point here is in Istio, and obviously Lin knows this, is we try to come up with themes for every release or themes for the year. And the theme for the past few releases has been operational simplicity and improved user experience. And what Lin said totally falls in that camp. I just want to give you an anecdotal story around, like, if someone is hearing this for the first time, they might be thinking it's counterintuitive. People want us to make microservices and then use Istio to simplify the problem. But then why are you going from microservices to monolith? And I totally get that. And that's why I want to put like some statements out there which make sense to people who are trying to deal with this dichotomy in a way. So I think, in my opinion, what's happening here is we went in the route of microservices, assuming there are a lot of different personas which will be managing different pieces of Istio. And that's why the microservices paradigm made sense. So you can have Citadel, which is issuing certs managed by security ops, and Pilot managed by somebody else, and Gateway managed by somebody else. But we found in reality is that most of the time there is one operator who is doing all the work, and adding burden on them to do upgrades and look at logs, like Lin said, for 20 different things doesn't make sense. Even though from the developer's point of view, we still have that logical separation in the code. So from development, the community point of view, from the working groups, we are still microservices. In the deployment model, we are monolith.
Yeah, I saw a very nice blog by Christian Poster talking about this stuff, actually. And I think one of the things we can all agree as engineers is it's better to look at something and go, oh, if we can change that, do it now rather than punt it a few years and then wish you'd done it. I'm not saying it's a mistake, but as in admitting sort of things change and reacting is actually a very positive sign of a healthy community, I think.
That's great to hear. Yeah.
Yeah, I think we both just said the same thing. It's just so nice to recognize, that what your users are suffering for and what are their needs, and then going back and looking at some of the decisions we have made. So that's definitely a sign of growth and maturity.
Very nice. The other thing that caught my eye, and it's a bit of a hot topic, bit of a buzzword, but the other thing that caught my eye in 1.5 is the WebAssembly support, the Wasm support. Yeah. So I wouldn't mind to get a few thoughts on what you both think of that, the potential, maybe the drawbacks with this kind of approach with Wasm as well.
So I think Wasm assembly support is really, really interesting. I guess for Mixer, you guys all know when Mixer was a single component, it was kind of on the path of data plane, right? Neeraj talked about data plane as part of the customer traffic as user travels through their microservices. Sometimes they have to go to the Mixer component to check if the call is even allowed. So that has been an issue for many of our users, and we actually don't like that actual hub to Mixer, and we don't like what if Mixer goes down, what if Mixer is in a different region or different zone deployed. So there was a lot of concern on that. I'm very excited to see the WebAssembly support in the community. I'm hope to see more documentation on this. Honestly, I haven't got my hands on a lot on this myself, other than the sample the Solo team put out, a really simple sample to replace the headers. But I see it as a tremendous value. I really think of it as kind of like providing Docker images, but proxy images to allow extensions into that proxy, which in our case is the Envoy proxy. So I do expect to see a lot of more movement of moving Mixer plugins into the WebAssembly runtimes and be able to distribute that runtime maybe into a particular hub like WebAssembly hub, and then other people can easily grab it and consume it in their proxy. I think that's a really tremendous value for the community.
Yeah, so that's the immediate tactical advantage, which is super important for the users. So a little bit on my background. So I have worked in proxies and load balancers for the past 3-4 companies. So data plane programmability is a big thing for customers. So I have worked, Aspen Mesh is part of F5 networks. I was part of a startup called Line Rate Systems, which was acquired by F5 Networks. And the reason we were acquired was we had Node.js programmability. Big IP is sticky for everyone because a lot of our customers come back and says, hey, we had Black Friday sale and I was able to write an iRules LX and save my site. So I think that's the power that WebAssembly gives you. It enables users to dynamically program with a much enhanced user experience. And I'm really excited for where this lands. I think this can be a game changer, not just for Istio, but the entire proxy landscape. Nginx has data plane programmability through filters for quite a bit now. Envoy had C++ filters, but they were really hard. Wasm, on the other hand, gives you a much easier user experience and developer experience. So, as a company and as a vendor, we have dual advantages. As a vendor, now I can make extensions for our customers without making a lot of custom changes within Envoy. Similarly, our customers can make some specific changes for what they need, which we might not be able to provide. So, it's really, really nice in terms of performance and security, because the security paradigm here is really nice in terms of VM isolation, the risk is low. You can't crash your Envoy even if you have a semi-faulty filter. I wouldn't say it is totally foolproof just yet. And from the performance, it's very native to the machine code. So overall, I feel like this is a big thing. I see a lot of good trends emerging from here in the coming months and years.
Yeah, I think the language is a huge thing. I mean, a lot of people having trouble with Envoy filter today because it's only in C++ or Lua, right? What if I don't know those two languages? I'm kind of stuck. I don't want to pick up a new language just to write my Envoy filter. Yeah.
Exactly. I mean, look at Nginx, for example, OpenRusty. There are so many companies which are just born out of OpenRusty. So, as a co-founder, I just see opportunities here.
I totally agree with everything said here, but it's my job to play devil's advocate today, yeah. So my background is very much in the Java space, and I did a lot of work on Netflix's Zool back in the day. And the beauty of Zool, it's an API gateway. You could dynamically inject Groovy scripts at runtime to change functionality. And it definitely, as you mentioned, Neeraj, you could denial of service rejections by dropping in a script that would, reject certain requests and so forth. The flip side was I made quite a bit of money as a consultant fixing lots of these gateways where people had put business logic in the gateway, or they'd highly coupled their gateway and the services. I'm a little bit concerned we might see the same thing with Wasm and Istio and Envoy. I don't know if either of you got any thoughts on how we might discourage engineers from putting too much into a plugin.
I think that's a really good question. And that separation is not very obvious and clear when you just start out. I think the community and all the developers need a bit of maturity to actually understand what should be in the application code and what should be as a dynamic plugin or a semi hack that you put in an infrastructure code, right? You want your infrastructure to be stable. These should be well thought out plugins. This shouldn't be, oh, I woke up at 12 in the night and I wrote something so that I don't have to change my code. So if I put on my operations hat or a security ops person's, I think this is as critical to any other infrastructure. You can't just drop plugins. Whether we will get there, we will. It will take some time, I think. But I'm totally with you that there is a concern. I think people like Lin and I, we should start educating now and get ahead of the curve a little bit.
Yeah, in fact, we're having similar challenging in the community. I believe, Neeraj, we had a discussion maybe a week or two ago. Some of these Envoy filters in the community, should we actually standardize and provide proper API in our control plane so user doesn't have to, build their customized Envoy filter?
Exactly. It's hard to differentiate. And, when there are easy bailout things that you can do or easy cop out things, that's what users tend to choose. So we just need to provide some guidance and guardrails, and then, hopefully the best thing emerges.
Yeah, I like it. I should say I've definitely made the mistake as well. I was sounding a bit judgmental earlier on. I've definitely built my own filters, which are not a good idea as well. So we've all done it, right?
If you look at iRules repository for big IP, you will see some crazy, crazy things. They're scary.
The thing is, if you can do it, someone will do it. Yeah. And again, I've been there, I've done it, particularly early on in my career. Yeah, it's all about knowledge. And I guess that's an interesting question in general. I'm guessing a big part of what you all do in the community with Istio is sharing this knowledge. Have you got any sort of tips on how folks might learn or how they might contribute perhaps to sharing this and building up this body of knowledge?
Wow, that's a great question. So I do find out we're making this easier for our user. I mean, it's still, at least the old perception from a lot of people was tremendous pieces for people to learn. So what we have been doing, it's working in progress in the community, is make sure our documents are easier to consume, make sure, people can adopt it based on their need and they don't have to learn everything. We've been trying to educate people like you don't have to learn Istio specific API if you just want to get certain feature like trigonometry, observability of your microservices. You only need to learn minimum Istio API if you just want to do secure your microservices. We had a lot of user having hard time with Istio API, mainly because of the networking API, which is actually very mature now, but there were people having a lot of hard time to understand gateway API, virtual services, and destination rule and service entry. And also, I think most importantly, how to having these API work together. How do I combine these resources work together to do what they wanted? That was a little bit more learning curve for people. So like in my book, I try to educate people, when you don't have multiple versions, you don't really need to look at the network API. I mean, we provide default retries for you. We have a little bit default configuration to plug in along. So I would say start based on your user cases and go there, and don't try to learn everything of Istio altogether because it could overwhelm you because of the rich feature the community provides.
Yeah, that's a really great point. I mean, if you try to do everything in Istio, it will take you a really long time. The other side of this learning, I would like to say, is there's one about users who are trying to use Istio for their advantage. And then there are people who are trying to invest their time and improve Istio by being a developer or being a community member. And I think we need to do better on both fronts. Right. So our community should be more receptive of diverse people coming in and actually making contributions. By that, I mean, we need to be making sure our working groups are more open, the meetings are more open. We have to make sure that it is in a time where it is appropriate for people from Asia and other regions, including UK and Europe, to join. So we are doing that. I think we are learning. It's really good to see more and more contributions, both as a developer and then also users coming back and saying, hey, I wanted to do this, but I actually couldn't do it, and then ask questions and go to GitHub and fix it. So I think we're seeing the entire spectrum. As the community is maturing more, I think both the user experience and the developer experience will be better.
Very nice. I wanted to dive into a couple of sort of more deeper topics now. The first one is around interoperability. I've been having some really interesting conversations of late around the service mesh interface, the SMI spec. I'd love to get both your thoughts on what you think the value is of that, how Istio is going to interoperate with SMI, for example.
So here is my thinking in general about APIs and abstractions. Any developer, when given a chance, will try to create another abstraction, thinking it simplifies life. So in some cases, it makes sense. In some cases, it does not. For the SMI, I think the benefit here is the operator can change the service meshes underneath. So at the face value, it looks like there's a reasonable advantage of it. But I have not seen much of customers in my day-to-day interactions who are looking to do that on every year basis. Like I will go to SMI, today I will use Istio, tomorrow I will use Linkerd, and day after tomorrow I'll use Console. So I get the broader principles and why you would want to go towards SMI and maybe create an abstract layer. But we have to see if one of these technologies are already emerging as the de facto standard. So this is akin to like Kubernetes versus Mesos versus Docker, and you know who won at the end. So I'm not trying to project anything. I'm not trying to say they're doing something which is not awesome. It's just that I think as a user, you should be making sure that you choose it for the right reasons. Like, are you really in need for changing your underneath infrastructure so often? That's my take.
Yeah, I think I'm kind of in similar boat as Neeraj. I think it's a little bit too early in the evolution of service mesh solutions and the user adoption today to conclude that we actually need a standard API specification to help our community, right? Think about how service mesh landscape today. We have so many service mesh vendors and each have their own implementation. Some have more features than others. If you end up using SMI, when you troubleshooting problems, you still have to kind of go in through the underlying vendors to troubleshooting the problem. So at the end of the day, you may end up needs to learn every single vendors that you use underneath of your SMI. So that's my struggle with it right now.
I think it's an interesting point about sort of standardization and the life cycle of a product. Definitely, I did a lot of stuff in Java and JCP, and we were only standardizing the boring stuff, the stuff that we all knew, the stuff that kind of we were building on top.
Exactly.
Exactly. Yeah.
But I also empathize with the SMI folks as well. I understand their goals. I think one of the things I've sort of heard around SMI is a bit like using HashiCorp's Terraform. Like the underlying sort of cloud infrastructure is all different, but you use a consistent workflow with Terraform. Now, I wonder, do you think perhaps maybe the SMI could be in that space in that it provides a consistent way of working? I could imagine, say, pick a number, 70, 80% of users in service mesh land really just want to do routing, observability, MTLS, the kind of basic stuff. Do you think the SMI could provide that consistent workflow across maybe your estate has got a bit of console here, Linkd here, Kuma here, Istio here? Any big organization is going to have a few things in the mix. Do you think SMI could provide value there?
I think once we know what those 70-80% use cases are, maybe. I think as those use cases emerge and as the space consolidates, we should see whether, like you said, the boring stuff can be standardized or is one API already the standard? Because getting users to debug two APIs is definitely worse than one.
So it really goes back to your point, how boring it can be, right? If it's consistently going to work for every single platform out there may be a value out there. And on the other hand, we also have to look at how is Kubernetes involved in this space, right? In the last KubeCon in US, I believe people are already talk about next version of the Ingress API. I'm sure you guys probably have seen it. It also have like route API. It has like virtual gateway API. So it's going to kind of building the standardize of the traffic API if that's getting adopted by Kubernetes. And if Kubernetes, everybody already agree it's the de facto standard for container orchestration system. So that may be the API.
Exactly. And I totally agree. And on top of that, I'm still not convinced if this is the right API to abstract. Most of the enterprise customers that I talk to, they struggle with, I want my application to work like this. Don't tell me networking APIs. So that's my other struggle with service mesh spec. It's still trying to abstract networking in more networking terms, but it's not talking to the language that people want to use, which is tell me my application behavior and then do whatever you have to do.
Very interesting. I think there's probably a whole podcast on that and developer experience and a bunch of things there, but a bunch of other topics I'd love to cover as well. Just picking another one, which I think, again, folks are asking a lot about at InfoQ, is this notion of multi-cluster support. And I'll put into that topic as well, and it might be an abuse of powers here, but the sort of what the Linkd folks refer to as mesh expansion too. So you've got multiple clusters, multiple Kubernetes clusters, but you might then have some VMs or some old mainframe stuff running out of band on your COBOL or whatever. We're hearing a lot about COBOL at the moment. How do you see that Istio and the service meshes dealing with that kind of thing, where there's not just one Kubernetes cluster, it may be many, there'll be other things in the mix too?
Yeah, so we already have a pretty rich support, I would say, around multi-clusters. So we have support in our official documentation around how you can set up a homogeneous multi-clusters of Istio, how you can have Istio maybe running in one cluster for the XDS serving, but on the other cluster, you also have a lightweight Istio running, but not doing XDS serving, just to manage the certificate and sidecar injection. And in the future, we're actually going to involve a little bit more in this space. I'm currently working on to have a little bit more configuration to have a central Istio D notion that people would just maybe have the remote cluster fall back totally to the primary cluster's Istio D. So that's coming. We also have replicated control plane multi-cluster pattern in Istio.io where people can configure heterogeneous clusters where the cluster doesn't have to be the same as far as the services deployed within the cluster. They do have shared single root of trust, but the services doesn't have to be the same. And you can configure like locality load balancer among these clusters. So to be able to fully leverage different functions provided by the mesh. We also have VM expansion support where you could potentially bring workloads on VMs to participate into the mesh. So you can have part of your services are running in VM and part of your services are running in Cube, and you could potentially load balance among the two. So that's also a hot space involving in Istio.io, but we already have some guidance for our user today on those.
Yeah, and we just added a new API called workload entry, which gives you a uniform way to use the Kubernetes primitives and say, I want to add these VMs, but I have migrated two of these VMs as pods, but now I want to load balance across PEDs and pods and VMs of the same services uniformly. So that's a really interesting API. I totally agree with all the options that Lin said. I think broadly the use cases are trying to do locality aware load balancing or trying to do a failover. And I think we are there, but we can do a much better job of making sure our documentation and the user experience is much better compared to where it is now.
Definitely. And one thing I would add is troubleshooting. Sometimes if you ever run through a multi-cluster scenario, you will notice if it fails, it's a little bit harder to troubleshooting today. So that's an area we definitely want to look into to provide more guidance and automation to our users.
These distributed systems, yeah, who knew? They're really hard, aren't they? Yeah, I hear you. That's great stuff. That leads nicely into sort of like wrapping up now. So what does the future hold for Istio and the service mesh space?
This is something that I've been thinking about for quite a bit, not just as a community member, but also for Aspen Mesh, since our futures are quite tangled. So I think there are some tactical future enhancements that I think are going to happen and emerge. And then there are more strategic ones. So from tactical thing, I would say multi-cluster support and multi-cluster being a reality is pretty obvious to us that that's going to happen. I see more and more users coming and saying, we have these many clusters, they are multi-clustered, tell me how can I do this versus that. Whereas last year, only Lin and I were talking about it. So it's more real. Second thing, which is more real, is I think the scale. I constantly see people coming from big companies like Alibaba and few others who are saying we have hundreds or even thousands of nodes on which Istio is deployed. Tell me how I can actually make Pilot work there. Tell me how I can make the control plane scale. So that's the thing that, again, as an abstract exercise we have done, but now it's real. So that's the immediate things that are going to change towards. The more strategic piece for future for me is mostly around three things. One, which you have already touched, about WebAssembly. I think WebAssembly will emerge and change a lot of data plane programmability and might emerge as a proxy standard. I really look forward to what customers and developers alike come up with the crazy things you can do, keeping in mind that that might be troublesome or create a new market for consultants. Who knows? A second thing, which is very interesting, which I've seen, is the application of service mesh in different business verticals. So this is around service mesh, Kubernetes. They started as a need for enterprises. What we are seeing is the same needs are relevant for telcos and 5G providers. And 5G vendors are going to take this space. They're going to make this a much more interesting problem and much more interesting solution, similar to how the telco vendors modified how load balancers used to be talked about. So I think this is very interesting for me. Similarly, I've seen some emergence in IoT sectors where IoT folks are saying we need to create an IoT platform. That platform does not look very different from an enterprise platform, just that we are talking about different protocols. So I think the long-term vision here should be how can we make service mesh or particularly Istio apply to other verticals, to other protocols without trying to reinvent the wheel, right? So I see a fair amount of momentum there. And I think as it advances, I think we will go in directions that we haven't thought about. So two directions which are really interesting is how can we make this work in constrained environments? So service mesh right now is deployed as sidecar proxies, which take up quite a few resources. Think about if you have to run a service mesh in a far edge 5G tower. So I'm really looking forward to that evolution. Similarly, performance, if you're trying to get this work for telcos, you have to be really, really high performant. IP tables might not work for you, so you might have to go to some really advanced technologies. So that's exciting, and really, I think that will push us to new innovation.
Yeah, I totally agree with what you said around multi-clusters, performance, and also WebAssembly provide new ways for user to be able to extend Istio. I guess from our perspective at IBM, we spend a lot of time on multi-cluster, make sure different interesting pattern around multi-cluster can work seamlessly for our user. We want to promote the central Istio D notion where Istio D doesn't have to be running on the remote plane. So that's something I'm driving in the community. We're also working on the community multi-revision. I think that's super interesting. You guys probably know Red Hat OpenShift already support like multi-tenancy. So I'm super excited to see the environment work group did a lot of work on multi-revision support in the community that allow users to be able to run multiple version or even same version of Istio D on the same cluster to allow user to kind of seamlessly upgrade between versions and also for multi-tenancy purposes. So that's tremendously useful feature to our users to kind of be able to kind of do a lot more testing before they move to the new version, and also isolate their projects by different meshes within the single cluster. So I feel like with kind of innovate in single cluster space, we also innovate in multi-cluster. There's also a lot of talk on mesh expansion and federated mesh. How are we going to connect two meshes together? So those are super interesting area. I'm expecting the community to continue to evolve and hopefully play a little bit ahead in the service mesh space.
Super. That's a lovely sort of insight into interesting roadmap items I think folks can look forward to and perhaps get involved with as well. So that's splendid. So just, the final couple of things now. If folks want to follow you online, what's the best way to do that? Twitter, LinkedIn?
Both for me, it's NRJPODDAR.
Yeah, they can reach me on Twitter, Lin Sun _UNC. I'm reasonably active on Twitter. I got a notification when Neeraj likes something.
There you go.
Awesome. Well, thanks both for your time today. I really enjoyed chatting to you.
Yeah, thanks so much for having us.
Thank you. It was really great to be here.